The directions say fill in the missing fraction parts. So I want you to pause this video and go ahead and try A, B, and C on your own. Use the pictures, the visual models of the fractions to help you. Play the video when you are ready to see back the answers. So you should have noticed that in this case 3/4 was shaded, and to get an equivalent fraction you had to shade 6/8. In letter B, 4/6 was the same as 2/3, and in letter C, 1/2 was the same as 5/10. Now this is the big question. What do you notice? I want you to pause the video and think about this question for a moment. Think about if you notice any patterns between the numerators and the denominators, and play back the video when you are ready to see a possible pattern. So I'm wondering if anyone saw this. If anyone noticed that 3 times 2 brought you to 6, and 4 times 2 brought you to 8. So we were multiplying by the same number in the numerator and the denominator. Let's check if that worked for letter B. Okay, so in letter B, well, this one goes the opposite way. So in this one, it was that 6 divided by 2 would equal 3, and 4 divided by 2 would equal 2. So that was, instead of multiplication, division. Remember, multiplication and division are inverse operations, meaning one undoes the other. So if we had read it this way, this would be 2 times 2 equals 4, 3 times 2 equals 6, right? It just depends on which way we look at it. And so interesting, we divided by the same thing in the numerator and denominator. Let's take a look at this one. Going from a denominator of 2 to 10, I am not multiplying by 2. What would you multiply by? 5. Okay, well, let's check what would happen in the numerator. This is also multiplying by 5. So maybe the pattern you noticed was that if you multiply or divide the numerator and denominator by the same number, you get an equivalent fraction. Well, there's a name for that, and it is called the equivalent fractions rule. Say it with me, and you have to say it with that much enthusiasm. You ready? 1, 2, 3. The equivalent fractions rule. We, all the rest of the year in math and all the rest of your life, are going to use the power of the equivalent fractions rule to make finding equivalent fractions much easier for us. And it states what we were just talking about. If the numerator and denominator of a fraction are multiplied by the same non-zero number, the result is a fraction that is equivalent to the original fraction. So you just have to multiply by the same number on the numerator and denominator. And here it is represented with some algebra, right? If we had any fraction, a over b, and we just multiplied by the same on the numerator and denominator, you would get an equivalent fraction. And in fact, this is not even a complete rule, because you probably saw right on this letter number B, it wasn't just multiplying by the same, it was if they are multiplied or divided. We could extend the definition even a little further. And I want us to think about that a little bit with just an obvious example. So 1/2 is a fraction we all are pretty comfortable visualizing in our head and familiar with. And I bet you could think of fractions equivalent to 1/2 for forever. You could just keep going and going and going. So let's say we did 1/2 equals 2/4. Right? You agree with that statement? We can picture these in our head and understand that those are equivalent. Well, so in this case, we did 1 times 2 in the numerator times 2 in the denominator. right? Okay, and let's look at another example still using 1/2. If we had 1/2 is equal to 50 100ths, well, this time to get that equivalent fraction, you could think, well, 2 times 50 got you 100, and multiply whatever you multiply by in the denominator, you also have to multiply by in the numerator. 50 times 50 would be 50 in the numerator here. So one thing I want you to notice is we could almost consider these fractions themselves. And this is why the equivalent fractions rule actually works. So if we considered the fraction 2 over 2, you would tell me that's the same as 1 whole, right? If we considered a fraction 50 over 50, you would say that's obviously the same as 1 whole. So basically here, even though we're multiplying by the same number, numerator and denominator, it's really like you're just multiplying by 1. And you've known for a while now that anytime you multiply a number by 1, you get itself, right? If I said, what's 3 times 1? You'd be like, duh, it's 3. And even if I picked a really big number like 3,452 times 1, you'd say, well, that's still just 3,452, right? Anything times 1 is itself. So that is why the equivalent fractions rule works, because you are basically multiplying by 1. So you're getting something that's still equal. I hope that blew your mind and that you love using the power of the equivalent fractions rule.